This is part of the GRDC project we're running. We're helping them out. We're doing 20 trials over 4 years, so the data goes into the NPK project that's headed up by Craig Scanlon. So the protocol that we've done in this trial is dictated by GRDC, hence the reason it's MAP. But you know, obviously with our products, we've got different products, AgFlow, etc. But to keep it standard, I think Summit are doing 20, we're doing 20, and I think GRDC are going to do 20 as well. So this trial here, seeded at the 18th of May, so we put down 20 event at seeding time, so it was either in MAP, so at 40 of P with MAP's got 20 of nitrogen. Where we didn't have any nitrogen, for example the nil plots, we put urea down as a nitrogen source at banded at seeding, so every plot's had 20 event at seeding, bar the checks. We then came back, we also had 15 of potassium down the tube with salt as our K source, so every plot's had 15 of K banded. We came back with 180 litres of Flexian about the 15th of June, and then we've also come back on the 20th of July with 150 litres of Flexian K. Now the reason we did that, it was to push the N up, but early plant tests showed that K was still limiting at 15 of K, so we just topped it up with another 15. So that means as of today, it's had the P based on the MAP. It's also had 125 of kilograms of nitrogen and 30 of K, so we've really pushed it to the upper limits, and potentially we're making a final decision in about 5 minutes. Ryan's here to go put another 60 litres on potentially this afternoon to make sure we push it up to around that 150, 160 of N. So what do we learn about this site? Probably the key point about this site and with all your paddocks is the value of soil testing here. So up here, what we've got next to me is the soil test. So pH, there was no issue with pH, anything. But just taking 0 to 10 soil samples into consideration, so this top line, the numbers look reasonably good. So a level of 31 of Colwell P, which is probably reasonably good. PBI of 80, which is classified as high, but probably not as high as what we see around a lot of this area. You know, we might push this up to 120, 140. And a Colwell K of 74. So with those numbers of just taking a 0 to 10 into consideration, we're probably looking at a maintenance level of P, probably no K, and you know, we're probably doing a pretty reasonably good job, or think we're doing a reasonably good job. What we've seen from this trial and what we've picked up in tissue tests and with comparisons of what we can do with trials is that even though the 10 of P looks reasonably good, we're probably not meeting the crop's demand. And that's because when we start looking further down the profile, so the 10 to 20 zone and the 20 to 30, we're really seeing this K drop off in a lot of our soil type. So 9, 7 down the profile. Also K, stratification of K, where it's been pulled up by the plant material and deposited on top, or you take it out the gate in your hay. So we're seeing elevated levels at 0 to 10, but really drop off levels as we get deeper in the profile. Now, one of the issues with this is that we don't know where this P is available in that top 10 centimetres. So we did some work where we sampled in 5 centimetre increments, and a bulk of this P is actually in the top 5 centimetres of the soil. So we're all banding seed, you know, couple of like an inch or so deep, or even deeper in the soil. So potentially we're placing our seed below where the high P concentration is in the soil. And also that top, you know, 5 to 10 centimetres, especially in the starts we've been having, has been dry. So if there's no soil moisture in there, the roots aren't going to get into that zone, and they're not going to pick up the P because it needs to be in soil solution for the crop to be able to take it up. So we're starting to think that these numbers, the 10 to 20 and the 20 to 30, have a lot more bearing on whether or not we're going to get a P response. So currently with CSBP, we're developing a new model. So we're looking at a 0 to 30 model for P recommendations. We've been doing it with these GRDC P trials for the last 2 years. This is the 3rd year. We've got 1 more year. We're seeing some really good results by using a 0 to 30, and we're actually building that into the new logic model as of the new version that comes out when Marty finishes in probably about 12 months. Marty, does that sound right?
Sounds good.
We'll see if we meet it. So what we saw with the new logic recommendation, so we put in a 5-tonne wheat crop, 0 to 10 only. Taking this into consideration, we're recommending 15 of P, 15 of K. When we took the whole 30 centimetres, our recommendation jumped up to 27 of P and 27 of K. Now we did put 15 down, and plant testing showed that that wasn't enough, and that was probably right for the K, so we had to top that up. And plant tissue testing also picked that up with the P. So hopefully that stays there for you. These are the actual tissue results from this trial taken this year. So as you can see, we've got a nil P here, 5 of P, 10 of P, 20 of P, 40 to P. Now the new logic system works that when you're up the top end of the sufficient, you're probably going to get 90 to 100% of the potential yield. And at this line, top of the marginal, you're probably only going to get about 75 to 80% of the potential yield. So even though it might say slightly sufficient, you want to be on the top side of sufficient to make sure that your plant's meeting its potential. So what we saw from here is that with a lower P, we're still getting basically a low sufficient in the plant test, but it wasn't until we start getting up to this 20 to 40 of P that we started getting towards the top of the sufficient range. So those numbers are based off our work and also work that's been done by DPIRD. So there's a pretty good correlation between plant testing and maximum yield. So the proof at this trial is going to actually be when we harvest it to see if that's what turns out and happens here. There's a bit of talk about DGTP and the value of that. Now, we have done DGTP sampling on all of these sites for the last 3 years. What we have found is that DGTP works reasonably well on forest gravel country with really high PBI. But as soon as we step off that sort of country, it's very variable, and there's no real correlation between a DGTP test and no benefit from doing it over a Colwell P. And it's a Colwell P plus PBI. So you need to have the PBI to make sure your Colwell P is a valid test. So that's pretty key. If someone's trying to talk you out of not doing PBI, you need to do PBI. The other thing with DGTP is that it's not ASPAC accredited yet. As a lab at CSBP, we do offer it as a service, but it's not ASPAC accredited, which is the Australasian Soil and Plant Analysis Council. So they audit all the labs and all the tests, and they give you a certificate to make sure that you're meeting their standards. So the other thing with DGTP is they actually wet the soil up and pull the soil to soil saturation before they test for P, which we probably all know that seeding time there's been probably a lack of rainfall, and having full soil profile at seeding time is something that we all want but not necessarily get. So potentially you might get an elevated reading based on full soil profile, but if that's not happening, what's in the paddock, your plant's not mimicking that uptake as what a Colwell P mimics plant uptake when we do the analysis of it. So I'll just go through last year's results before we walk through the plots. This was a trial we did last year straight across the road. So same P response trial, looking with wheat, MAP, I think we got to about 120 units. But what we saw, a really strong P response. So 0 of P grew us 2.2 tonnes, 5 of P gave us about another 600 kilos. The next jump up gave us about 3 tonne, 20 of P gave us 3.5, and 40 of P gave us 3.8. So what that means that we probably think with the curve fitted, 30 of P, 27 of P, what the new logic was pretty much where we needed to be. For every dollar we put into phosphorus, we got $6 back by doing that. Now the hardest thing to do is 30 of P when you're coming from 0 is a hard jump, but it's even harder to go from 15 or 20 of P, where a lot of people are, to this 30 of P. And last year's trial showed that for every dollar we spent on top of what we put, the 15 to 20 of P, we got $3 back on it. So it's still quite economical to make sure that we put P on to get up to those higher rates. Now when we go to penizzas and duffs and we look at where we're trying to really push the envelope and grow a lot of crop, push the top of the yield response with a lot of N, one of the problems is that if we don't get our P right at the start, it becomes limiting when we try to put on 150, 180 units of N. And that means that you're cost effective, you actually start blowing your costs out because you're just pouring money in and it's not the limiting factor, the limiting factor is P. So the beauty about phosphorus and getting it right at the start is that you set your crop up. So this is something that you can't get wrong because you can't fix it in season. So you set your crop up and then means for the rest of the year, all you have to worry about is the nitrogen lever to pull, and you can play the season with nitrogen quite easy. If it's dry, you stop putting it on. If it's wet and the opportunity is there, the potential of the crop's there to meet that expectation if you want to get there with nitrogen. Rightio, so we'll walk down here, we're going to start at the wheat, and then we can finish off at the 40 of P with barley, which is probably my favourite plot. We haven't put any phosphorus on yet, so this has had 30 of K and 130 of nitrogen already, 125. If you're looking at it in isolation, it doesn't look too bad. If you had a crop of this, you'd probably think, geez, that's not looking too bad. But what we are seeing, when you compare it to where we can go higher up the P applied scale, is that it's slower in maturity. So we're seeing that this is starting to fall behind in maturity. So we're about probably a growth stage to nearly 2 growth stages between this one and the 40 of P. So delayed. The problem with that having delayed maturity is that we start coming into terminal stress in the next sort of month with it warming up and the heating up and the moisture running out. You really want your crop to be filling and making sure it's getting the wheat and maximising that yield now or in the next sort of month, rather than being 2 or 3 weeks late when the stress hits, and it will start dropping its yield potential. So, other important thing, I don't know if I've pulled it out. I did, I'll try and find it. I did have a wheat head out, but someone picked it up and chucked it, but that's all right. So we saw a real difference. I've pulled some wheat heads out of this nil P. Currently it's setting up, so P pretty important early to set your head length. Head size in this one's looking between 6 and 7. When we moved up to the 40 of P, we're starting to get into about 10 and 11. It's starting to set high. So big difference there is that you start growing that head length early with good P rates, and you get a favourable finish of the year, you can start, that yield starts really kicking up because you've got 10 high, then they start going 2 wide, 3 wide, etc., etc. You grow a lot more grains per head. Where in barley, it's probably not as pronounced in barley, but definitely in wheat, making sure you've got good head size is where you can maximise the yield potential. So this one here, crop stage, I think it's flag -1, just coming into flag. It's probably much more pronounced in the barley. So $11 spend to go up to 5 of P. Definitely a good jump in height. Looks a lot thicker. Just probably looks like it's performing not too bad. Tissue tests still come back as that is marginal. And another $11 to get us to 10 of P. So 10 of P is probably slightly below district average, I would say. So still looking pretty good, but I think there's still a slight jump up between 10 and 20. So a lot of us are in here with our P rates between 10 and 20. The difference, $22 a hectare. It is a cost, but $22 a hectare difference is about 50 kilos, 50 kilos to 100 kilos of wheat. So if you can get 100 kilos out of this, you're starting to make extra money compared. So P could be the driving factor. And then we jump up next to the 40 of P. She's a bit wilted now. So that's about 9, that one. So yeah, different head size. So we're starting to see bigger heads and that developing. That head's not far to come out of the, so that's flagged now, coming out. So we're probably a whole growth stage. So something to just be wary of, that delayed P, a lower P or no P can delay that maturity. It's something you see quite a bit.